As mentioned, my name is Mizell. I run solution engineering at Overops. From a way of background, I'm a software engineer by trade. Actually started as a network engineer, and my title was everything with a plug. And so it didn't matter what it was my problem. And my boss came to me and said, you have to take over development. Our software engineers stink. And so I started in Power Builder, dating myself for any of you guys who are familiar with Power Builder, data windows rule, right? And then switched to Java, actually for a company called McCamish here at Powers Ferry, if any of you are familiar with his software for insurance companies. So rewriting in Java. Then that company sold to Infosys. So I quickly bailed. Probably makes sense to most of you, right? And so I took a foray into solution engineering and with a company called Terracotta. So if any of you are familiar with the Cache, Terracotta was probably one of the most fun jobs I've ever had until I came here. So this is my cheap segue into, we're also hiring. And so if you like what you see tonight, come see me afterwards. I have solution engineering jobs and technical account manager jobs in this foray, so it's pretty fun stuff. I spent 4 years at Hadoop land at Hortonworks. So if you guys have done any Hadoop, I feel your pain. And now I'm at Overops. And so the reason I chose to come to Overops, and I will share some painful stories that may resonate with you, maybe not, through my experience. Is it okay? It just seems super loud. Kill it. Yeah, it's super loud. Is it okay if can you guys hear me okay? Okay. So as writing software back in the day, as most of you can imagine, when things go wrong, trying to get context and have information is the biggest pain. And we write everything to the logs. And then when it doesn't show up in the logs, you don't know. And when I saw this product, I was like, I actually had this idea about 10 years ago, but didn't have the ability to build what I'll show you tonight. It was an eye-opener for me. And so that's why I joined. So just give you some quick context. So we're going to talk about continuous reliability. It is a huge passion of mine. When I wrote software, I did not like pain. I don't know if you guys like pain. And if you're an SRE, actually, let's do a quick survey. Who writes software? Who's a developer here? A majority. Awesome. Who is DevOps? So you got a big mix, some of both. Who's site reliability? A couple people, site reliability? Okay, awesome. So the biggest thing is I learned from pain, right? I hate to have the same stuff happen to me over and over, the whole out, right? And when Sarbanes-Oxley hit, like when I used to write software, we could deploy it into production too. And that was okay. And then that stopped. And so what happened is I had to throw it over the fence to DevOps guys, and they never deployed it right. Sorry, guys. Because it was always their fault, right? It was infrastructure's problem. It was something else. And the biggest challenge is trying to get a pipeline going. And there was not a lot of automation. We struggled with scripting, and we did a lot of stuff manually. I mean, how many people here still deploy manually, like take the WAR file and put it in Tomcat and restart manually? Well, that's impressive. Oh, you sort of raised your hand. When I spoke at DevNexus, I think over half the people there raised their hand that they're still deploying manually, still doing manual QA. And so this whole pipeline thing, how do I move faster, right? So in the world that we live in, you have to deliver software faster than ever, right? The Amazons are eating the world. Guys like Home Depot, I know some of you are here, and other companies have to keep up. And so how do we get to this continuous reliability pipeline, moving data, or moving our code faster into production, right? And keeping it stable. So we'll talk a lot about that. We'll talk a lot bit about the challenges of delivering quality and then this path forward that we're seeing. And so I work with a lot of big companies on this challenge. So I'd love to get your feedback on this. I built this Venn diagram. It's very analogous to what we used to talk about with caching. You get 2 of 3, right? So it's hard to get all 3 of these all together, right? So if you think about it, if I want to go fast, I have to give up either complexity or quality, right? It has to be easy. If I want to get quality, then I'm going to lose speed or complexity, right? I can't have all of them. It's impossible to get a balance of all 3, right? And so if you think of the term of continuous quality, I love this part. It's a probability of a piece of software operating without failure while in a specified environment over a set of duration time. In a perfect world, a reliable piece of software is completely defect-free, does not create downtime, and performs code correctly every time. Anybody have that? I've never seen it. Wouldn't that be great, right? That's it. So what are our challenges? I know you guys have seen this, but I always love putting it up there, right? This is really actually the truth, right? Code is really not truly tested till it's in production. I mean, that is a fact. We do the best we can in lower environments to test. We build more code coverage. We do as much as we possibly can, but you put it out in the wild, and that user uses it completely different than it was intended. They put in different data, they do something different, they do some scenario no one never thought of, and what happens, right? It causes problems. I mean, that's just the facts. And so the challenges are, I think a lot of us deal with technical debt, legacy debt, right? That is a huge challenge. I can only imagine the folks that work down the street where I used to work, where I wrote the software, and I'm not there anymore. I was a chief architect. I knew every nuance of that software. Our whole team is gone, right? I don't know, how many of you guys deal with that? Got a legacy app you own now? Original developers are gone, and so it becomes a struggle. We all depend on third-party libraries. I bet most of you don't even really realize how many problems are in those libraries. We actually have done a lot of work with customers, and when I show you what OverOps does, because we monitor apps and detect errors in code, most of the third-party libraries throw hundreds of millions of errors while you're running and you don't even know it, right? And these are problems that are causing and manifesting other problems that people just don't know. It's actually quite insane, and we depend on these. And how many people have had, you see some of these vulnerabilities come up where there's actual security breaches and issues in them, so we have to do static code analysis, you have to do all these things. It's where we're at, right? It's what we have to do. I know nobody has finger pointing where they work, right? Nobody blames anybody. We're all the same team. It's all happy. No, we blame. Everyone's blaming. That's the biggest challenge, right? And I heard the automation. Someone's got, I think it was you. We need automation on our team. That's what's the only way to get past this. Eliminating human intervention, the more automation, the better. And we have a lack of it right now. And then there's really, truly a lack of observability, right? We don't have insights into our apps the way we want. If we don't write it to the logs, it doesn't exist. It's the only way we can debug. So those are some of the challenges we see. And then there's a lot of legacy things. I'd love to know who's doing manual code reviews. So extra large shirt for the guy, extra large or large in the pink? Extra large. For manual code reviews, right? Isn't that fun? Woohoo! Hated the manual code reviews. Absolutely hated it, right? And we still do it, right? We still do it because we have to. There's no other way to be able to check code because we got to have some sort of a check, right? Anyone doing manual testing still? Oh, yeah. Oh, yeah. So next shirt, way back there. Is large, extra large for you in the blue? Yeah. Large? Ready? Not bad. Good catch. I love it. Manual, right? So this is the thing. We try to automate as much as possible, but the truth is there's a business person or a QA person that's going through a test case, right? We're doing this manual testing. So I got to give you the story of the day. So when I worked at this company, McCamish, we offshored to a team in India. I'm sure some of you have done that. It's a lot of fun. They were creating more bugs than they were fixing code and writing code. And I know no one here has felt that at all. And so we decided that we were going to backcharge them for errors. So if there was bugs, we were going to backcharge them. So we told them this. The next release came, and our manual testing, they tested all the test cases, and everything passed, and everything was green. And they were like, yay, the offshore team got it right. Thank you for saying you're going to backcharge them. They stepped up. We went into production at Hartford, MetLife, Lincoln, SunTrust, others. And the first call came in like minutes later, no data saving to the database. I'm like, what do you mean? Like, well, we went through this whole new wizard, we entered all this data, but nothing's saving, but there was no errors. They swallowed the exceptions. Completely couldn't get it to work, so they swallowed them, and it passed the test. The QA person said, yeah, it finished. There was no errors, right? But nothing actually saved. So it took me about a month to unwind, right? So it was going out, seeing what's going on, and then finding all the places that they swallowed exceptions. That wasn't too hard to find, but I had to fix all the code. Took weeks to unwind that, and it was a huge red scar. Yeah, manual testing is great, but it's that human intervention part, right? And then, of course, I talked about manual deployments. It's good to hear no one else is doing that. It's good to hear. So questions I like to ask, right? So how do you know when to promote code? And I'll just give you some of the stuff I've heard, and I'd love to get feedback from anyone who has something different. Our head of QA gives us a green light, right? They say, okay, everything looks good. I love it when we query APMs or logs to see if there's less errors than the last time, I can't make this stuff up, right? I'm not kidding. I hear this all the time. There's less errors than last time. Promote, right? Don't have a choice because management tells us, right? I actually was at a customer today, and this guy had an if condition that they wrote on the board. It says, if dev says, if the developers say it passes, promote to QA. If QA says it passes, promote to pre-prod. If pre-prod fails, promote to production. And he said that actually happened because they forced him, and it bombed, right? It happens. How do we know if we've introduced new or resurfaced errors? We don't. I mean, all the tests have passed. We don't really know, right? And I love this one. We do a lot of regex queries against the logs. Okay. I mean, I hear a lot of people try to do things to try to figure it out. My favorite is now the developers, when they write new code, they have to give us their error string, like what error message they're writing, so we can do a regex. You see what I'm talking about? They do a regex query in Splunk, and if that detects it's new. Like, that's the only way, right? So it's crazy. We don't know. And then how do we know release over release if we're improving? No one really knows, right? Like we hope and pray. Less customer complaints, right? Less sev ones, don't really know. So these are the challenges, right? So the path. What's the path, right? That's what everybody wants to hear, right? I don't really know. Thanks for having me. Appreciate the time. So what's the path? So this is it. We need to build better pipelines, right? Smarter pipelines. The challenge is on the left side in development, you have more visibility, right? Like I can see more, I know more, I can fix more in that realm. But as I move to the right and I deploy to these different regions, my visibility goes down. And like when I get to production, I have none, right? Because devs don't even have access to that data. You don't have any access, right? So we need feedback along the way in a more automated fashion, right? I need to know. So how many people are using like static code analysis? Right, it's like a Sonar Cube or something like that. And you're starting to put it centralized, right? So there was a day when it was on our desk. We used to use check marks. We'd check it anyway, right? But you put it in that central spot, it stops the build. And then if people get alerted that need to get alerted, you have to go fix it. So I need feedback sooner. And so that's the path, right? I need to get smarter pipelines with more alerting and feedback to the right people. And so on this roadmap, I've got these key trends that I kind of track. How do I get to this continuous reliability, that little, ohm spot, that perfect spot in the middle, right? So it's automate. Automate, automate, automate. The more human intervention you can take out, the better you get, right? Because humans, we make mistakes, right? Know your unknowns. Remember the swallowed exception story? Can't make this stuff up. When you don't know, you can't measure it, you can't understand it, you can't fix it. How do you know? Like, how do you know? I've had a lot of people that have unhandled exceptions, and they're not using even a higher level logging framework that catches everything at the top. And if you have an unhandled exception, your thread dies. How do you solve that? You don't. It's one of those things that you're in for weeks, right, in the war room. Identify errors sooner. So is everybody on a big shift left world? Everybody shifting? Not a lot of people. Shift left is huge, right? Trying to find stuff sooner. And so there's a big push for shift left. So better test coverage, more automation. If we leave it to finding it in production, obviously that's the problem, right? So we want to shift left. Get to knowing sooner, and I'll cover that with you guys. Capture more context. This is one of the biggest things I see, because we all rely on the logs, right? At the end of the day, it doesn't matter what APM tool you're using. It doesn't matter what modeling tool you're using. Any of the tools that are out there, we all go back to the logs, right? And if it's not in the logs, it doesn't exist. And if the developer didn't give you good context, you have nothing, right? You have a stack trace, and that's where you start. And then you get into experimental fixes and trying this and that. And how many people close a bug? Works for me. I used to do it all the time, right? Works in my environment. Like, I don't know what's wrong with you, right? So that's it. You need more context. You need more data. Create more better code coverage. I think there's a lot of new tools emerging that are now looking at how much of your code is actually tested. Because look, as devs, this is one of my favorite stories. As devs, I hated building test cases. You guys, anyone here like building JUnit tests? Oh man, that is absolutely a shirt right there. Large. You like to build who does that? I hated building them, right? I hate building those tests. I love that someone actually loves doing that. So there's a lot of tools now that are actually looking at it. We actually asked the guy, we were talking about this the other day, he's like, I asked my devs to do more code coverage, and they test getters and setters. Really? Hey, it works, right? So no one actually, I mean, when you write JUnit, do you assert the method, or do you actually test a code path, like a use case? Yes. It depends. Most people test a method, right? I assert 2 times 2 is 4. Great, it passes. Not everybody tests the entire code path. That's a challenge, unless you have, like I used to use Load Runner, and I could test a wide range of things, but most people don't get that deep, and you need to, right? You need code coverage. Metrics. Anyone building a metrics hub? Oh man, shirts are rolling. I love metrics hubs. Tell me what you're building in.
So starting off, it's just like logs.io, because they give me like the alt stack as a service, and I'm one guy.
Yep.
And so I'm just shipping logs right now from like just PagerDuty and Jira, Service Desk, and soon to be like 5 other things, and then eventually I'll get a better UI and get more data and overlay more data sets on it.
Yeah. Got to start somewhere, right? The interesting thing with the metrics hub, it's funny, if you guys have seen, there's a lot of companies that are trying to go into AI ops, and it's the fun buzzword like MuleSoft and stuff. So I come from the Hadoop landscape, and we did data lakes, right? The whole idea was to get all my data in one place and do predictive analysis and do those types of trends. That works great for like heavy machinery and operations and stuff. But if you think of it from a data center perspective, how good is the data in your data center from an application or infrastructure that's a year old? It's changing every day, right? You guys are deploying apps all the time. The infrastructure now, we're moving from hardware to software, right? So we have software-defined networks now. I can change the network direction with a flip of a switch. So the network, the way it looked a year ago to where it looks today is very different. Your application from what it looked like last week is very different. So there's only so much data you can store, but you need a metrics hub to bring it together. You need, I think, like the last 3 to 6 months of data becomes valuable. System metrics from your apps, network information, all that stuff together with errors and that type of stuff, you can actually start to look at trends and patterns. And the idea is to try to see what the inflection point was that caused issues, right? And that's the challenge. It's tough to bring it all together. I'm starting to see a lot of metrics hubs show up. A culture of accountability. Anyone have that challenge? That's a huge problem, right? We were just talking about that when we walked in with a couple people. If you're a developer and then you throw it over the fence to the ops, right? It's their problem, right? No longer yours. I see that a lot of culture of accountability problems. No one wants to take responsibility for the problem. And then what we get is more problems and more problems, right? So that's kind of the path. That's the path to get to that coup de grace, all these key components. So let's dive into those. So automate. You have to have more automation. There's a lot of great tools out there, but like for me, static code analysis tools are huge. You need a static code tool like anyone using like Veracode, Black Duck, security stuff, right? If you're not using security analysis tools, you're vulnerable to all the open source projects you're downloading. Every day things are found, right? And you're just exposing yourself if you're not doing this. There's a mix of tools that are used for automated testing, right? So you got some people in the room who love it. I would hire them if you can get, that want to build JUnit tests, want to build code coverage. The more code coverage you get that's automated and repeatable, the better. So when I got burned with that swallowed exception, I got Load Runner and started building mass amounts of tests, right? The more I could do, the better I could get. Short run, long run, you want to do endurance testing, you have to automate this stuff and look for code gaps. So there's some tools out there. One of them's called, I think it's called JRebel. No, not JRebel. That does hot deploys. There's a couple of new tools that are out there that are looking to see where what you don't have covered. So I would look for tools that help you detect it automatically where you don't have code coverage and look for your gaps.
Regression test to fit test.
What's that?
Fit test, it checks the quality of your unit test.
Okay. There you go. That's good to know. If you guys look into this stuff, right? It's important to know. Limit the manual testing, right? So we talked about this. Limited to no manual. That is, it's a weak spot for you, especially if you're moving faster, right? If I want to get to faster place, I'll take a 2-second digression. How many people here deploy every day? Every week? Every other week? Once a month? Every other month? 6 months. You got a kind of a range, right? We're working with customers who are taking monoliths that they deployed a new release every 6 months, and they're trying to do it every day, right? That's a hard problem to solve. How do you get to deploying every day if you have manual work in there?
We called it 90 days of hell. We went from quarterly to weekly.
Yeah.
And it turned out to be 102 days of hell, but
Yeah.
90 days of hell.
Yeah. Yeah. It's crazy, right? It's a culture shift, and it's a shift to this automation, right? Dynamic code analysis. This is what OverOps does, right? So a way to automatically detect the issues in your code, deduplicate it, alert, and measure your code for you. So I like to call it code monitoring code, right? So something monitors your code. I'll show you how this stuff works later. And then feedback loops to the right people, right? So that's one of the things we talked about with the static quality gates. It's a stopgap. Do the same thing with dynamic code, right? So I want stopgaps along the way that tell me, so I don't have to go figure it out on my own. I don't want to go looking through logs, grepping through logs. Actually, honestly, we had a customer that they were trying to build a culture of accountability, and they had their developers, every time they release, tail the logs for 2 hours to see if there's any errors. I think I'd quit that job in like a day. I'd sit and tail logs, right? So no one wants to do that. I want to grep logs. So I want to automate. So automation key. Know your unknowns, right? So we talked a little bit about this. I don't know about you, but I don't want any part of no pointers, index out of bounds, the classic, ridiculous, non-defensive coding things that we see in code all the time. I don't want to know them, right? I don't want to have things that are slowing down, right? And so that's what like APM tools are for, like detecting what's not running as fast and why. You know, it's a great example of this. Like we had the application I wrote, we had a piece of code that checked to see if you're adding a duplicate license, right? I can't have a duplicate license number. So the person that wrote it, it worked just perfectly fine when there was 3,000 contracts. When we did a merge of another system, we added another 1 million, it failed. What this person did was actually query the entire database, pull it back, iterate through every row in memory, and see if it found a dupe. Well, that's fine when there's 2,000. When there's 2 million, it crashes. So these are the things, how do you detect them? Like you don't know, right? There's no way to know until it crashes, so we need to get ahead of that stuff, right? And it's nice to know if errors are happening more frequently. So this is an interesting thing, right? So something that was happening 100 times a day, and we were like, nah, it's okay. All of a sudden it's happening 10,000 times a day. I'd like to know. I'd like to know this stuff. It's an anomalous behavior, right? And then I already gave my story, this whole swallowed exception stuff, which is absolutely painful. So knowing this type of stuff is super important, right? So that's that know your own stuff. Shift left. So this is a huge thing, right? So especially if you're deploying faster, it's test early and often. So I don't know how many of you guys use Jenkins. Any other automation tool, build tool, like TeamCity? Okay, so what's that? Drone. Any of those? So the idea is, you see this when you start getting to this full automation, is as soon as code is checked in, a build is kicked off. Just automatic, right? And so you'll have multiple pieces of code being tested in parallel. So I checked in code, you checked in code, you checked in code, and there's a bunch of builds going in an automated fashion. And there's static code analysis, dynamic code analysis. There's all your unit tests are running, and things have to get approved and passed. And that's testing early and often. I'm constantly testing. Amazon, Google, all these cloud platforms have paved the way for this. Back in the day, we only had a one QA region, so we had to wait for it. I have to ask, anybody still waiting for a QA region? Yeah, painful, right? I can't do any testing until I have it. So the beauty of automation is I can spin this up faster, right? And then I want to get feedback back to the devs as soon as possible. So this is the quality gate, and I'll show you this later, but we have 6 quality gates in OverOps from a dynamic perspective. I can tell you what's new, what's resurfaced, errors that are increasing, the critical exceptions I talked about before, like class gas exception, no pointer, if you want to detect those. I can also give you counts. So instead of querying Splunk to see if it's less than last time, I'll tell you how many unique and how many total errors you have, and I'll give you a quality report with context back to those errors. So again, just another way to get more context and get, move faster, right? And this is the more context screen. I'll show you this live. I didn't do that at DevNext, but I'll show you it live how OverOps does this. So I'll just skip over this for a second. I'll show you it in a second. This code coverage thing. So there are actually some new tools. We talked about that detect it, but there's some new tools that actually will generate unit testing for you. Has anybody used any of those? Not yet, huh? I stumbled into a couple of them at a couple conferences that I've been to, DevOps conferences in New York. And they're actually automatically generating different use cases for you. You provide some data, and it'll actually generate the code coverage for the entire code path. I'd be interested if anybody's ever tried one of this. Sounds like no one here has, but it's something that I think is going to start to emerge more because devs don't want to write them. As you can see, 3 people raised their hand out of 30 or whatever. Nobody wants to write them. So there are new things coming up. We actually are talking with a couple companies where we can provide the data that we get to the test case so it actually can build it. So it might be interesting. So it's something I think that's definitely worth looking into. The metric stuff, so I talked about it, Metrics Hub. What's interesting is if I can correlate application errors to CPU usage, to memory, to threads, to network bandwidth, you start to see the trends and patterns that are going on. So I've worked with several companies. Not only are we troubleshooting and solving the errors, but when we're fixing these errors, they're actually reducing CPU usage. So if you think of what's happening, how most people scale today, just add more nodes. Right? No one really knows how much one node will handle. So we just add more nodes. And of course, Amazon is happy to charge you for more nodes. And the price goes up quickly. And so we actually were able to take a customer that had 300 nodes deployed down to 150 by knocking down a couple of large errors. And when I'm talking large errors that are happening over 1 billion times a day. And they didn't even know it. So think about the CPU network, the Splunk ingest cost that is. Having that type of data is huge. And so knowing it, being able to correlate it, and knowing that you're improving over time is huge. So I'll give you kind of a couple of screens that we do. And actually, I'll just show you this stuff live. But one of the things we're heavily focused on is scoring apps now and being able to show you release over release improvement. And I'll just show it to you live. It's probably better. The last couple things, and then I'll show you some live stuff. Culture of accountability. This one is really hard for me to see because it's become acceptable to have errors in apps. And I'm really surprised by this. So when I joined OverOps, like when I wrote software, it was not acceptable. We had a policy, 98% bug free, right? And so we didn't have the number of errors that I'm seeing today. And when we turn OverOps on for customers now, I kid you not, we have people that have 1,500 errors in one application, unique errors. It's crazy, and some of them are, swallowed exceptions that are code flow, right? So I don't know if anybody done that code control flow using exceptions. A lot of people do it. It's an anti-pattern, but it's out there. I see it a lot. We see a lot of repetitive things happening that are just not needed in apps, but they happen, and it's crazy, and it's counted acceptable. And so then it becomes, I blame this guy. And so what we're saying is like, look, it's time to change that status quo, right? The amount of errors in the apps, in my opinion, have an error. They have a cost, right? And the cost is, how many times do I have to reboot my app so that it doesn't run out of memory, right? Like that's standard practice now. People reboot every 12 hours because the apps are running out of memory. Now we're moving to containers. Guess what? When the container dies, a new one spins up. So memory leaks, problem solved. Sorry, it's not, right? But I hear it all the time and I see it all the time. That's become acceptable. Why, right? So we've seen a lot of companies go after bug bashes. Actually, one company is doing beer and logs. That's their bug bash. So beer and logs. We search through the logs while we're drinking beer, which is fun, but we search through the logs to fix the errors. I wonder what new errors we create when we're drinking beer, but that's still fun. But that's the process. So the things that we do to try to build a culture of accountability, in my opinion, is we do bug bounties. We've seen a lot of companies do bug bounties, and we actually are starting to see some companies give bonuses to teams with the least errors. So I want to share just like a quick thing. Like when I ran my dev team, we had a whiteboard but that was kind of sat in the middle of the room with all of our tasks. We actually did Agile before Agile was Agile. Had a bunch of tasks on the board, your name was on it. If you broke the build, your name went on the board. And my name was on the board a few times. Not that I wanted to be, I ran the team, but look, I took it. But the thing is that what it did is my boss could see it and other teams could see it. They started doing it. No one wanted their name on the board, right? So your only name would stay on the board for a week at the most, and it would be erased. And the idea was to not have your name on the board. And that builds a culture of accountability. That's a team. We're starting to see people do a reverse of that. Show me my top developer, right? People that want the top teams, the apps with the least amount of errors or the least sev ones. Anyone doing this kind of thing at their office? Yeah?
A long time ago when I worked in an office, we had two things. One, when you broke the build, everyone on the dev team got emailed. When we first turned this on, everyone on the dev team got emailed every 30 seconds. Great way to be brought back to the office on a Friday afternoon.
Yeah.
After that, we replaced it with the build rack. We had this tall, hideous, slightly not safe for work doll that if you broke the build, you had to proudly display this doll at your desk until someone else broke the build.
Yeah. It changes.
Somebody who had a hawk from Baywatch. He's one of the 6 foot tall boys. When he broke the build, she would bring it and put it in the queue.
Yeah.
She loves telling that story.
Yeah. But I tell you what, it changes the way people work, right? Like, I don't want to have my name on the board. You don't want to have that doll. Like, nobody wants that. But if we don't have something like that, then we all have to deal with sev ones. Anyone like the 2 o'clock in the morning calls? I don't, and I was on plenty of them. I hated that stuff, right? So you build that culture of accountability, everyone's in as a team, and it changes the outcome, right? So that's one of the biggest things for me is culture of accountability, everyone working together, and you have to have it, right? You have to build something. So that's my view of the path too, right? We talked about all these topics. Now I'll do the shameless overops demo because I think it's important for you guys to see. I'll take questions as well. So from a perspective of overops, we've got a few different ways to view it, but this is a very developer-centric view. But the idea is overops capture, I'll just take a step back. Overops is a native agent. So if any of you guys have dealt with APM tools, you know what an agent technology is. Yes, sir. So we're a native agent. We are actually attached to your app when it starts up. And the idea is anytime there's an exception, overops captures it, right? And we capture the exception and we actually give you, deduplicate and give you great context, right? So we'll deduplicate to the event and the location in the code. And we'll tell you how many times it happens and at what rate it's happening. Now, my favorite part of the rate is when you see 100%, that's not an exception, that's the rule, right? I mean, that is happening all the time. Why is that code even there if it's happening 100% of the time? So that's a huge eye-opener for me. I've never seen tech that'll tell me how often it's happening. And then you can start to realize, is this happening at a ridiculous rate? Some of the most interesting ones are the ones that are happening like this. 1.2%. Those are the ones that are hard to find. Happens rare occasions, happens at Tuesday at 1 o'clock for 20 minutes and then stops. We see this stuff all the time, and those are the hard ones to solve, right? And so we give you amazing context. We'll tell you when an error first occurred, what version it occurred in, that type of stuff. Then the magic is, and all developers on the planet love this, this was the eye-opener for me. When I can see, when we capture an error, we actually take a snapshot, and the snapshot is a point in time the error occurred. We'll decompile your source code and overlay the data over the top of the variables. So it's just like being in Eclipse going through debugger, stepping through, except this is a snapshot in time. So it's not live, snapshot in time, so that way your app is still running, no loss of performance. But now I can see and come in here and say, hey, here's all my data for every object, not just where the error happens. So if you think of a stack trace, if I write out to the log some context, which we tend to do, it's right at the point of the error, or if I use higher level exception handling, then I don't have any data. This is method over method for the entire thread stack. So if I go through this entire stack trace, I've got data all the way back to the entry point in code. So a lot of people send payloads like a JSON or an XML or something to an entry point. I can see the payload that came in, I can see the response that went back, and all the data that happened along the way. It can also, this is another one of my favorite ones. How many people have to go and turn on debug logging to get more context? Yeah, all the time, right? OverOps will capture info, debug, trace statements for that thread stack, so you don't have to do that, and then we'll keep them for you. So that way you have that context right there on the screen. So just more context to help us. So for that thread, here's all my log.infos, which is nice. And we'll also give you JVM stats. So this is at point in time, so not like a generic number, right? So this is point in time. For having this type of information, we actually help people solve problems like thread blocks. Like you can actually see what the threads look like at the time of the error, right? I can see what the JVM's looking like, what the environmental variables look like, all of that kind of context. So that really is the sweet spot of what OverOps did, and it was really built by developers for developers. And so the idea in the beginning was, let me capture this data and really heavily in production. That was the idea. But what we found over time was the data that we collect is actually more valuable in a chef left in an ops view, right? So this type of data, giving these calculations and stats, is huge. And so what we did is we surfaced it in some better visibility tools. So now, this is Grafana. We can actually show you by app how many new errors, increasing errors, slowdowns, those types of things. But one of the favorite things that we do now is this notion of tiers. So if you think of your application as the center of the universe, it's connected to a database, to a queue, to a caching solution, to whatever. And a lot of times when an app is having an issue, nobody knows why or where. And so then the war room starts, right? And we start ruling out network, database, whatever. Well, in OverOps, we can actually tell you it's your Kafka queue. We can't do puts or gets to it. We can't read to your database. The inserts are failing because the string is wider than the column allows, right? Like we can tell you all this stuff. And so we break out these code tiers, and we actually have a lot of customers. And this is all done at the code level. So like com.jdbc, com.kafka, apache.kafka, those types of things. So it's the code level. You can actually do your own. So we have a lot of customers that say, well, I call a third-party service. So you just use the package name or the class name and give it a name, and it'll show up as a tier. So then what happens is then we start having customers say, well, wait a minute. We also don't know which errors to fix first because we have so many. So we did this notion of a weighted average. So we're actually scoring apps now, which is kind of interesting, especially when they're read like this. But the idea is which errors are the most impactful, because it's hard for any system to know. Like I don't know which errors are the most important, or costing you the most money, or not working. But what I can tell you is we can stack rank them based off of your input. So is it the type of error, no pointer, class cast exception? Is it in a certain piece of code? So one of the things that I think is awesome about this is I can actually say, I'm on the DAO team. And if there's anything in the DAO layer that's failing, that's critical, right? Because that's revenue generation. So you can say this specific class or this package is a Sev 1. If anything fails there, mark it and tell us about it. So we stack rank all those and give you a score. We also let you compare. So I can compare day over day. What's different? What's changed, right? I got new errors today. I can actually do a comparison between yesterday and the day before. And I can actually see release over release what's improving and what's not. So surfacing that data is helping QA teams, dev teams, SRE teams have more visibility. So it goes back to the things we talked about. Metrics matter. Visibility matters. Context matters. Like having this, MTTI, MTTR just dropped, right? Like I don't need to go and do experimental builds. I don't need to go and figure out what the stack trace failed. I can tell you right there, I've got the actual line of code right here that failed. And I can tell you, here's the data, here's what happened, here's the use case. I don't have to go figure it out. It's telling me exactly what to do. So now I have the context I need, have the metrics I need. That's the notion of what OverOps is about. The last piece we do is, yes, sir?
Is this aggregated across all instances of an application type?
It is. So what we do is when you bring an application online, you name it, right? So I would name an app, or I would name an app group. So if you have microservices, let's say there's 5 microservices, and it's one application, you would name it, and then it's going to give you statistics by those apps specifically. So you know what app it is. We can actually tell you what server it happened on, right? So sometimes the errors only happen on one server. So we can give you those type of granular views, and it's all rolled up, obviously, to the app itself. Yes, sir?
Is there any way, or feature that allows you to figure out which microservice generated a call that is causing an error in a different microservice?
So now you're getting into distributed tracing, right? Yeah. So in the distributed tracing world, it's a hard problem to solve, right? And so we've seen a lot of open tracing standards and those types of things. And at the end of the day, we write to the log, right? It's all writing to the log. So, well, where OverOps plays in today, I'll tell you where we're at today and where we're going. So where we play today is most people use a logging framework. And if I'm using open tracing or Zipkin or any of those tools, I'm generating a UUID, writing to the log. As I jump from service to service, I write to the log. OverOps, when errors happen, will inject this tiny link. And this link will show up in all your log entries. And so if the entry happened, down in, A called B called C, and it happened in C, you'll have every log entry from A and B and C entry points because we'll log it. But when the error happens, you'll get the tiny link, which will take you back to the OverOps exception. But every log event you write, OverOps captures log entries too. So we'll have every log entry and the error. So we'll be able to help you replay it, and you'll have click links back to OverOps. Future state, we're working on tying it all together. So the idea is, and this is future state, probably second half of the year. This is a monolith, for lack of a better term, right? I got this huge stack trace. The idea is we want to be able to stack together all of the calls and replay it in one frame or several frames, and you can step through them. So we'll be able to link those transaction IDs back together and be able to let you step through it. So that's future, but today we have to work with the log because that's what people are doing, and we're trying to find a way to make that seamless. Does that make sense? Mm-hmm. So speaking of this is, most people, that's a workflow thing, right? I work in the logs, I search the logs, I live in the logs. I have some stickers up here that say log files suck. Anybody wants them? Because they do, so they're up front. The other piece is I think I talked a little about, showed you this, but the Jenkins component, right? So a plugin that lets me set the gates I want, new, resurface, total error, unique errors, critical exception type, increasing, and then getting a quality report, right? And that report tells me what passed, what failed. I hope you can read that. And then the link that takes me back to OverOps, right? So again, that feedback loop that we're trying to give to our developers, right? So I've got a gate that says, hey, there's a problem. It alerts everybody, and then they come and they work the report, and they get the context they need to solve the problem, right?
So you're not just targeted at production, you're targeted at steps in the Jenkins pipeline.
Yeah. So like I said, when we started, it was built for developers by developers to solve production problems. But what we're seeing is the data we serve is better, and in a shift left world, why not try to stop the stuff from getting to production in the first place? So if you think of the continuous reliability, if I have better code coverage, more automation, code monitoring code, I might be able to stop more things going into production. And we're seeing it today with customers that every time they run a QA release, there's 20 new errors. Would you promote code into production if you knew you had 20 new errors? No. OverOps, well, I want to say we would choose not to. Doesn't mean that it won't happen. Since OverOps, we index at the bytecode level. So it's bytecode, method, class, package, and fully qualified near-war jar. So we know uniquely that code has never been seen, and we can tell you it's new, right? And that becomes very interesting. Because if I can tell you these 5 things are new and give you this root cause screen, you can quickly ascertain, is this important or not, right? Because there's a triage portion, right? Because there are some errors we're going to accept, unfortunately. But if I said there was 5 new ones and you looked at one and said, wait, the new payment thing's failing, you're going to fix that. So I've given you the context to move quick, right? So that's why that's the value of OverOps. So I think of that whole continuous reliability that we talked about. Metrics, giving you all this insight, right? Giving you the context behind all of it. One of the things that we started doing, because as I mentioned to you, there's so many errors in apps. I apologize, this is a Wi-Fi, so give it a second. There's so many errors in apps, nobody knows where to start. And so, I chose the wrong one. How about that? We started stack ranking errors. So we're actually telling you which are the most critical by an algorithm. So again, trying to think for people. So here's the errors that are most impactful because it's a certain type of error, happening at a certain rate, those types of things. We want to give as much context so that the new errors you can focus on first, and then there's a notion of bug burn down, right, per sprint. And so if I can choose and burn those down, I would choose to do that. I would hope I would choose to do that. Here we go. Sorry, it's taking a second here. So like in the screen, like these are all my new errors, and I can tell you, hey, these are priority ones. It's a no pointer, and it's swallowed. There's a swallowed exception, no pointer. And here's my secondary ones. And then out of my unique errors, which I have 363, here are the priority ones. I stack rank the whole thing. So again, just trying to give more context. That data serves SRE teams, dev teams, so much more context, right? Yes, sir.
Where does the data for all this live? And the reason that I'm asking is, say I put this dynamic scan in my Jenkins pipeline, I let it run for X amount of time. What if my Jenkins environment's ephemeral? Would it break? What do I have to do to set something like this up?
Right. So the data that's stored here, the metrics data is stored. If you choose to go, like a lot of people are not cloud averse. If you're not cloud averse, we have a SaaS offering, and it's stored in a SQL database in Amazon. So you don't have to worry about anything, right? All the updates are updated automatically. You get all that magic. If you choose to go on-prem, it's a SQL database at the end of the day. So we have a Tomcat front end, SQL database. As all of your unit testing is running, remember, we're not monitoring Jenkins, we're monitoring your app. Units being run, Selenium, whatever tests are being run, part of your automation, we're capturing all the data, shipping it to it. If Jenkins goes away, it doesn't matter to us, right? All the data is still in the database.
So that might be a pretty heavy agent if it's exporting like millions of logs, as you say,
Not logs, not monitor the logs, monitor the app. We are a very lightweight agent. So we're a very new school agent compared to the heavy APMs. And so we're judicious with the snapshots we take. So you saw the snapshot with the code and the variable state. Our algorithm says take 2 the first hour, 1 every 24 after that. And we keep the metrics. So the number of times it's happening, the rate at which it's happening, and that's 1-minute bursts of data. And it's all telemetry data, so it's super lightweight. Just,
Masking?
we do. That's a great question. It's actually not masking, it's redaction. So the first thing everyone asks me is, you're showing me my data? I don't want to see that. So we have full data redaction. We don't mask because it's risky, so we just redact. We do 4 methods. Regex, so we have standard regex patterns out of the box, like SSN, Social Security, or SSN, credit card numbers, that type of stuff. But then we do variable names. So you can just put in the variable name, and then we do classes and packages. Yeah. No, so we don't do anything with Splunk at all, but remember, we don't monitor the logs, we monitor the app, but we actually instrument the logging framework in your app. So Log4j, SLF4j, Logback, whatever you use. And when you log is getting written, we just inject that link into that. Not into Splunk, into your log framework. So, and then, yeah, Splunk is where it goes. Like if it goes to Splunk, if you're using Elk, if you don't use any and it's just in your logs, it'll be in your logs. Yeah. Just trying to make it easy for people to get context. All right, probably consumed a ton of time. Any more questions? Yes?
This is a broader question. I was at a presentation one time where a business person gave this perspective that there's a business value to code not getting production, or a business value to getting into production. And so there's a threshold whereby the number of security bugs is low enough that the code edit, the corollary is that the standard rule should be to put it in the bugs. Is that a common perspective that you encounter? And what is your thought on that?
It is. That's an awesome question. So there is that notion of the value of what we're putting in is higher than the number of bugs that are going in with it, right? I think that's your question. I've heard that a bunch of times, and there are trade-offs to all of it, right? And that's the risk assessment, right? The problem is the people making that statement don't know the number of bugs they're putting in, and they don't know the outcome, right? So the toughest challenge is what's the risk, right? So I'll give you some examples. So my wife is an online shopper. I think we all are anymore, Dow's, right? So on Cyber Monday, this past Christmas, she bought from her favorite online store, and the shopping cart disappeared. Like she put everything in, credit card, save, gone, nothing. Tried it twice, nothing. So let me ask you this. How many people here would go somewhere else? I would. How many people would pick up the phone and call? My wife did. She picked up the phone and called. So the funny thing is what is the cost for both of those? Cost A, person goes somewhere else. I don't know about you, but I can tell you for myself, my own personal experience, if that happens to me, there's no going back to that website for me. I'm just that way. I don't know why. I've always been that way. If it's not fast enough, I'll give it one chance and I'm done. If it fails like that, I'll just go somewhere else. There's other places. Then you have the other side of, so that's a lost customer for life, right? The other side of it is my wife picks up the phone and calls, so they got the sale, but they have to pay the support person to be on the phone because their website stinks, right? So there's a cost associated to both. That's a minor one. I'll give you a big one. How many of you guys are Wells Fargo customers? I am. Everyone knows that story. You know when they had that outage a month ago? They were out for a day. People were tweeting, I can't buy gas because my debit card is all I have. How many of those customers do you think are there? Right? What do you think the fines are for that? What about Boeing? Software glitch caused people to die. Those are the risks, right? And I get where those assumptions come from. And you have to keep up with business because it's such a challenge. Because in today's world with the notion of the cloud, a company can spin up in Korea and put you out of business tomorrow, overnight, right? I mean, that's just the facts. The things are happening so much faster than they used to. Do you guys remember when we used to go and rent movies at a Blockbuster? That's gone. But do you know what's happening to Netflix right now? AT&T is going to pull the plug on all of the shows they have and start their own. Disney's going to pull all the plug on all the shows they have. So this is the world we live in. So you have to move fast, but you have to weigh the risk, right? I think it's a tough risk. I'm glad I don't make those choices, right? I couldn't imagine saying, yeah, deploy it. The risk is low. I think if it was something that had to do with people's lives, I would clearly not deploy. I would never take the risk. But if it's something like shopping online, you take the risk, right? I think it's a choice. I think if people had better metrics and better data, they would make better choices. And that's why OverOps exists, because there hasn't been anything like this before. And having that data, you can make a better choice, right? Long story. Sorry about that. Yes?
So you mentioned AOps before. What are some vendors or tools in that space? I mean, everybody's got the dumping ground that winds up in Grafana, but describe things I hadn't heard before.
So Moogsoft is probably one of the bigger vendors. And actually, Splunk is trying to do this. So the idea is they're taking data from everything. They don't create data, right? They have to consume it from everywhere else. So they want all your network data, your JVM data, your whatever app data, anything they can get. Most of it is they want to get as much telemetry data as they can get. And so if you think of like what Splunk's doing is they actually have to write something that parses the logs to try to generate statistics because they don't have metrics. They have nothing. And so people are trying to use stuff like StatsD and those types of things to try to get data into a format that's consumable. But you have to have a ton of sources and sinks and agents to get data from everywhere in. And then what it's trying to do is look for patterns. And so if I have, like we have I ran this customer that every 6 weeks they have an outage that costs them 8 figures. So they reboot every 4 weeks. So they don't. They're trying to figure out the 6-week problem. How do you figure that out? So if I have the app data, like if I could have all the error insights and they look at CPU, memory, JVM, all the statistics, you're trying to look for an inflection point. That's what Moogsoft and these companies are trying to do is predict what's going to fail. Well, what if I got 2 months of data and then I dropped the monolith and I have microservices? Well, that last 2 months is worthless because it's all new. So I think that's the challenge is how do you get to that predictive nature? And they're trying, AIOps is a cool term, let's be honest. I actually worked for a company that was a GPU accelerated database, and we were doing a lot of GPU predictive. I wrote a predictive algorithm to predict, use linear regression to predict car sales. That's something that's static, right? I had this many car sales for the last 12 months, I can predict the future, but you can't predict something that's moving like this. I think it's tough, but there are companies trying to do it. I haven't seen any success yet, but they're trying. Yes, sir.
So I think AppDynamics is doing well in AI ops, and I think that they offer a really similar like application insights at the application level, and also at like a distributed trace type level. And I know that they offer like a support for like a wide variety of languages. And I want to ask, because this seems like a lot of the features here are Java specific, like this object relational. What languages, I guess, do you support?
Yeah, good question. So I'll hit the two things. So app is a Java agent designed for performance. They do give you most error counts, not everything, so they can't get down deep with swallowed and handled and stuff. They'll give you some stuff, but they'll give you stack trace at the end of the day, right? But they're really great at telling you where you have slowdowns. And they'll tell you the method, but that's it. Now you have to go figure out why. We'll actually give you a snapshot of the code and the data that was failing or slowing down, right? So the two combined work very well. We actually have an integration where they detect a slowdown, it'll auto-fire a snapshot and overops. So that's the differences in the two, right? But from a perspective of code coverage, yes, they're a mature product. They've been around for 15 years, or maybe longer. We cover Java and .NET, or JVM, I should say. So Scala, Groovy, Kotlin, those, and .NET framework. We are working towards Python, Golang, and Node second half. So we've been around for about 6 years, but only really as an enterprise company for the last 2. So still pretty young.
I know, so in Go, there's like a couple of standard library packages, Peepoth and Trace, that let you see like exactly what line of code like added to your memories. So like how much heap was allocated and like the syscalls that were being made, which are both really interesting. Is there any sort of like relation to what we're seeing here?
So
I'm just asking because it was cool.
yeah. So I think we don't have anything like that. I think what we're working to that would be useful is helping you detect like memory leaks. So Java 11 exposes, we use JVM TI, if you guys are familiar with that, low-level APIs that Java exposes. It's fun to go look at. They're actually exposing the memory footprint. So it's kind of like if you ever use JProfiler, we'll be able to get that through JVM TI without disrupting your app. And if there's a memory leak, we'll be able to actually capture the data and tell you the defending objects and what classes they're in. That becomes very interesting, right? So that's second half of the year. We're actually working on some other stuff to help with log reduction and detecting PII data in logs. So since we're so low level, we're working on things that no one else is doing just because we have that capability. So it'll be nice to see some of the differences that come out with these tools, right? I saw another question. Yes, sir?
Do you have plans to cover the client side and the browser exceptions as well?
So on the client side, the problem is you can't put an agent on a browser, right? So we're agent tech, no code changes, which makes this awesome. On the client side, there are a couple of open source projects that you have to change code to capture. We're working on some of there's some embedded things you can do to try to capture more data. So you'll see some stuff from us coming from a JavaScript, from a mobile device here shortly. But the problem is we won't be able to get this type of deep context, but just having the information I think is useful for a lot of folks. So we'll see more of that coming. We're trying to get to the point where it's closer to this, but it's just so hard because you can't put an agent on someone's laptop, unfortunately. So, any other questions? All right, so I've got a couple shirts left from OverOps. Anyone? I can throw it right at you. And I've got a ton of. Let's just take a look at these. We've got this pretty awesome. All right. Oh, wait. This one here is pretty cool, too. Let's take a look. All right, way in the back. You got to come up, though. I don't know if I can get it that far. Oh, see? It held up in the wind. Was that the wind? Oh, that's awesome. Root at whatever, get, pull, origin. Anyone? All right. And I think, is this too? Jacket? Ooh. Oh, this is like old school, like armless. All right. All right, so there's some stickers up here if you guys want. I'll be around if you have any questions. I appreciate you coming. I hope it was useful. And we'll see you guys next time.